this saves the health systems millions and billions of euros. To have people, especially younger people, getting back on their legs again, back working again. And so this is a really hot topic to make this process more efficient and more reliable, because it just fails in a lot of cases, even though everybody does the best of their knowledge, because we can't get this MDR regulation, made a lot of confusions, a lot of problems, because all old products have to be recertified. There is a huge clog up of all the notified bodies that could do the certification. Sadly, this is something that makes the European healthcare or classic real medtech industry that's fully regulated currently a really big headache.
Hi, and welcome to Beyond Pitch, a podcast for the most visionary founders and out-of-the-box products. And today we have a founder and CEO of a next-generation soft sensor technology called Sendance. Really welcome, Robert. How are you doing today?
Thank you very much for having me, Raghav. It's really a pleasure to speak to you this morning, and it's gray outside and rainy, so I'm happy to have a cozy office to sit in.
That is great.
So I'm looking forward to our session. It's a really great opportunity for us.
Happy to hear that. Just to let everybody know that I guess you're in Linz right now.
Exactly, in Linz in Austria, right at the Danube between Vienna and Salzburg.
Perfect. So let's dig into it and let's understand what is the big vision that you're pursuing forward.
Yeah, we founded Sendance actually because we had a common vision. It's a spin-off from Linz University. So there is an institute that deals with soft materials, the physics of soft materials and its application in electronics and robotics. And there were a lot of really cool sensor technologies being developed at that institute, but in the end, you write a paper about it and it's left at the drawer. And I came to that institute in 2019 after, quitting my first startup job. So after the exit, at some point, if the startup is being drawn into a bigger corporation as a founder, there's just not really a space for you anymore. It's not the same work that you want to do. So I came back to university. I met my future co-founders. And they asked me, how is it to found a startup company? Because that might be interesting to make use of these great technologies that are being developed here. I said, yeah, okay, we can chat about it for a minute. And if you're not careful, then you end up being CEO. That's what happened to me. And but because we had this kind of common vision that we wanted to use this technology to help people, because there is the potential in that technology that it's being used, being put to really good use. That was also a motivation for me from my first startup, where we did man-machine interfaces, also in an industrial context. But at some point, I always had this impression, it's a cool technology, it's commercially interesting, but if it didn't exist, it wouldn't matter that much. So I wanted to, in the next startup, that is Sendance now, I want to do something that really has an impact, that really helps people, change people's life for the better. And
that's really wonderful, and it's funny that you end up being a CEO. That's a good story. But yeah, let's dig into the problem. What is the problem that you're solving?
So the point is, there are a lot of manufacturers of healthcare, sports, fitness, nursing devices that are usually mechanical in nature, and that are adapted to the human body, either by being soft and stretchable or by being manufactured exactly to shape. There's a lot of handcraft in medical technologies, especially in orthotics and prosthetics. And that changes now more and more into being digitized. So people are scanned digitally, then you put that data in the 3D printer, the printer prints it, and then you fix it to the patient. And that makes it much more efficient, the process. That's cool. But what all these professions, all these companies are lacking is a feedback loop to the people wearing their devices. And they would love to offer digital services to get feedback about how their devices are doing, to be sure they're safe and efficient in what they're doing, so they can offer better services to the people out there. And to achieve that, they need sensors in their devices. But these devices are soft. These devices are individually shaped, because humans, don't fit into a one-size-fits-all box. So especially if they are in need of supporting devices in healthcare, they often tend to have not very standard body proportions. So something is, happened to them because of age, because of disease, because of accidents. So it's really important to offer these companies an easy way to integrate sensors, electronics in their devices that opens this feedback loop or makes it accessible. And that's what we are addressing at Sendance.
Definitely makes sense. And if we try to delve into these manufacturers and try to understand how many of these manufacturers are looking for it, so how big the problem is, and how big the problem will get in future, looking at the manufacturers who are trying to personalize their products. How about that?
Yeah, that's the point. It's a huge opportunity. The market is already really huge. For example, just orthotics and prosthetics in this field, custom-made devices that are really fitted to the patient are already a 16 billion market worldwide. So, and there is a large centralization of the whole manufacturing and this whole process happening there, because it's moving away from an artisan working in his workshop, serving a few customers per week because of all the work only one person can do, to making it digital, sending the manufacturing to a central fab where it's 3D printed. And so being able, a single orthotic technician can then serve 10, 15 patients. And so this is really playing into our cards, because that's the point where it's easy to integrate our sensor technology and where we have large customers that we can serve that distribute our products, because we want to be the providers of the sensor technology that is integrated into devices by our customers. And our customers know how to make devices that really help people, like orthotics and prosthetics companies, like sports equipment companies, like nursing technology companies, all those companies building wheelchairs, building beds for all elderly people or, people that can't move much, and so on. And all these companies, or many of these companies, want to have this digital feedback loop, but don't have the means to really develop these devices because it's really risky. It's a technology, there are no standard technologies available. You have to set up all this supply chain for production, and afterwards we have to deal with the data. And that's also what we supply. We're not just supplying sensor hardware, we're also supplying a digital backend that helps in designing the product or adapting the product to be a digitized product, down to managing the data that comes out of the sensors.
That's great. And if we look into, so if you want to summarize all this product is for the manufacturers who are trying to build personalized products and have a feedback loop at the same time to fasten the whole process. Right? Okay, so that makes sense. And now if we delve deeper into the product and what you are building on a technological point of view, I know you have different pressure sensors and different kinds of sensors and what you're building in those products. Can you tell us more about it?
Of course. I'm really happy to do that. We have our product kind of has two main parts. One part is the sensor hardware that we call Sendance Grid, which is not just a sensor, but it's a method how to integrate sensors into these soft and individually shaped devices. You can imagine it's a rubber grid with single points integrated in it, where the sensors can be located. We developed ourselves pressure sensors that are superior to most that are on the market. We can integrate humidity sensors, strain sensors that see how the grid is deformed, if it's in a soft environment especially, position sensors in a magnetic field, and temperature sensors, which are easy. And we can also integrate sensors on customer wish. Everything that's a small SMD component can be integrated easily into this silicon rubber grid. And it's never touching, the electronics parts are never touching the skin of the patient. It's all embedded into medical grade silicone. And the whole thing is stretchable, so it can adapt to individual shapes, and it can adapt to the movements of a textile, of a soft foam that's really touching the human body and conforming to the human body. The second part, and there is readout electronics that can aggregate the data and send the data via Bluetooth or via a direct IoT connection to a gateway device, which could be a PC, could be a mobile phone. And this then is connected to the internet, and there runs our Sendance cloud, which is a medical certified cloud database where you can manage the data from the device, not only the direct sensor data that is generated during use, but also the exact data, how the device was produced, because this is really important in individualized devices. You want to have the sensors not always at the same location or a single standardized sensor in a wristband, but you want to have them distributed and exactly where they measure the right thing. And our sensor hardware can be produced just like 3D printing in a one-on-one production process. Basically also some kind of additive manufacturing. And the software is equipped to deal with that. So you have kind of a twin of the device in the back of the database, and the sensor data is really connected with the physical twin, with this digital twin of the device. So you know exactly what happened when you get the sensor data.
That's interesting. And if we have to look at from a case study point of view, let's take an example and try to understand, for example, that you said prosthetic leg. And you told me that it is something that this product will be really useful in the future. So how would that work?
Exactly. A prosthetic leg, if a prosthetic is fitted to you, you lost your leg. This happens to a lot of people, sadly, not just because of accidents, but mostly also because of diseases like diabetes. And this will not go away. This will get much, much, much worse in future. Then there are two parts. One part is you have the amputation stump, so the remainder of your leg, and you have to fit the prosthesis to this stump. And for that, you need a specially fit so-called socket that makes the prosthetic leg really fit to the stump. And then you have the prosthetic itself, which is made of rather standard components, where you, depending on which parts are missing, you have a foot, you have a knee, joint. These are wonderful, very complex devices. But up to now, this socket, where this prosthetic is connected to the human body, is a dumb device that's made with a lot of artisan knowledge, and it's a very complex process to do that needs a lot of attention of a highly specialized worker. And that makes it really tricky currently because these workers are in short supply. In a lot of countries, there are actually none of them, or only very few. So, there are no prosthetic legs really fitted well, and that means a lot of people that could, get to walk again, just, are confined to the wheelchair because there's just no way they can get a well-fitting prosthetic leg. And this socket is what we want to address. It's individualized. It has needs a certain kind of flexibility, and we can, with our Sendance Grid technology, integrate sensors in there, send the data out, and the orthotic technician during the fitting of the device gets a direct feedback. The patient doesn't feel anything in his leg. It's just been cut off. The skin is somewhere else where it was before. He just feels pain, but he doesn't know where it is, so he can't give feedback. So that means with this sensor system, the orthotic technician directly gets feedback how the socket is doing, and can make the fitting process much faster and much more efficient. And the patient has much lower risk that when using the prosthetic, he gets abrasions, pressure sores that would kind of inhibit the rehabilitation process, because then he can use the prosthetic for a while. And it's really important to get these people very fast on their legs again, because they forget how to walk, actually. If they keep for a month in the wheelchair, they will not be able to use the prosthetic as well as if they get it inside of the first month after the operation. And this is really a crucial process, because that saves the health system with all the following costs of people not being able to walk anymore. This saves the health systems millions and billions of euros to have people, especially younger people, getting back on their legs again. feedback working again. And so this is a really hot topic to make this process more efficient and more reliable, because it just fails in a lot of cases, even though everybody does the best of their knowledge, because you can't get this feedback. And even in a long term, it's good for the prosthetic wearer, for the amputee, to get some feedback from the socket, because the amputation stump is not a static system. It changes in shape because of muscle atrophy and different hormones, just eating more or less. And so the socket needs to be adapted, and it's good if it's adapted as quick as possible, because else you might get pressure sores, you might get abrasions and things like that. And the sensor data could help to improve the gait of the people, how they walk, which then again has a lot of beneficial side effects on the joints, on the back, gives less problems. So this is a huge topic, and there are hundreds of thousands of people alone in Europe affected by that.
Sounds interesting, and I agree to that, knowing that creating a prototype every time you have a new patient, that's a tedious process. And that's where I guess the sensor technology would be really helpful. And if you just to consider what kind of sensors would be used in just this specific case.
In this specific case, pressure sensors are the most important ones, definitely, because they just give you the kind of shape of the interaction of the leg with the socket.
Do you also use, I know you have other kinds of sensors like temperature, pH, and all that stuff as well. And that you have like much more comprehensive data where you get an input from the pressure sensor or the temperature sensor, and then you build a comprehensive outlook of how the patient is, let's say, feeling when they have the leg in the socket.
Yeah, so the major pain point is really this is dealt by with the pressure, but we also have there is thoughts of extending that, if they anyway wear it, to extend that to also humidity and temperature sensors, to just give a certain warning. Okay, you're wearing your leg now for too long. Something might happen if you continue wearing it. Please, because those, as I said, these amputees need to relearn to feel how the leg, what their leg is doing. And this process can take several years. And for some people it works better, for others less. And these could benefit a lot from the support of a system that tells you, okay, be careful. You might get abrasions, you might get pressure sores, things like that. Right. So this kind of multi-sensor system would be more interesting, for example, in nursing, where you have a wheelchair where people are sitting all day, that perhaps cannot communicate that well there, but still feel uncomfortable if things getting wet. There might be incontinence, there might be sweating, or if the temperature is not comfortable, but they cannot communicate as easily. So for people taking care of the person in the wheelchair, it would be a big help to just be reassured, okay, I can go out of the room and I will get some message if something happens that makes the person in the wheelchair uncomfortable, because this is an extreme load also on the nursing personnel or on the people taking care of disabled persons, that they always have this kind of bad conscience. If I go away, I might, these people might be left alone in a really bad situation. So to have this kind of remote monitoring might be an incredible help also for those people that take care of the people with disabilities.
Definitely. And I think that this product solves a lot of problem as a horizontal product in different verticals, for example, sports, healthcare. And there are other competitors also building the similar product. I remember we talked, Sensoria is one of them, which is building the shoe sole based on the sensors. And I believe this product can also solve that, but the technology that Sendance uses is patented.
Yeah.
If I'm not wrong, right? And this patented technology is widely used, and it cannot be used by any other competitor. So if we compare the product with other competitors, let's say like Sensoria, what are the, let's say, competitive advantages? Because I guess they are already in the market. They are partnering with other companies and so.
Yeah, so as we know them a bit better, and they're actually, I mean, seen from the website, you would think they are big in the market, but they're also a startup. They're not much older than us, and also not much better funded. So, but they are very well connected, and in the US market, they have quite good access. So currently, we're not, they are focusing in the US, we are focusing in Europe, and they address a bit of a different clientele. So they are focusing much more on very high volume products with much less customization, because their technology is not coping that well with customization as ours. So we see our niche where we have the strongest USP in product lines with 10,000s of products sold per year, but more the high value products where we can also respectively charge more for our services and for our hardware. While Sensoria and other producers, for example, IEE in Luxembourg, they have printed electronics technology, they have the sensor foils. We are in contact with them, and they are only interested in cases where it's millions of pieces sold per year. So in that sense, I think we have our competitive advantage mostly in those cases where I have this high variability. We are prepared to tackle it, but that means we have to go more horizontal, because a single customer and a single product line will not take us to a billion revenue. But seen over the application range, this is of course a much bigger market even than just a few product lines where you have low margin, extremely high volume products. So we have we stay with higher margins, lower volumes, but setting up more and more customer relations and getting more and more product lines in place. And with the high versatility of our technology, this is possible, and this is our USP compared to our competitors. We also address that really in our whole digital backend, that at the end we want to go also downwards, even that we want to offer in future also a self-service platform where people can do their own prototypes, and everything is completely automatic. So like the makerspace, 3D printing, additive manufacturing space is going towards, that you are having your online CAD software, you design what you want to have, you can upload scans you did yourself, you press on a button, this thing is shipped to you the next day. And no human is ever involved in that process, perhaps by putting a stamp on the package in the end. Everything is completely automatized. And this is the vision where we want to plug into, that we deliver the electronics part of that. If you design this product, you want to design this product with sensors, that's fine. We are the providers of the platform for that.
That's really interesting. If I look at, if I try to understand that, if I want to make let's say a kneecap or something that I can put up on my sleeve, I just get the sensor and print it at my home and use it myself. So that's really user-centric, and I really like it. From B2B, we can also have a B2C in future. The customers can directly access it. So this is actually really nice. So if, let's say you said that you're looking for people, customers or manufacturers who have higher margins, but let's say I am a manufacturer and I come to you and I produce, let's say, shoe sole for just an example, or I want to get the sensor, and how much would you say initially the time duration will it take me to get the product, and how much it can cost me to get this?
Exactly. So we did already 21 of those pilot projects, and by now we have the experience that we can say the model that we use in our financial planning is that we screen our customers, and if you're now coming to us with a product vision, and together we say, yeah, that makes sense, we should try that out. then you would first engage in a pilot phase where we build together a prototype. We offer these prototyping services to you for around 10,000 euros. It will be a 2, 3, 4 months project, depending on capacities and communication speed. And then afterwards, you have a prototype and you have a clear indication what will it cost, and much better view on does it make economically sense? And then there is another gate where we say, okay, is this a serial product that makes sense? And then if we get this check on that, because on both sides might say, okay, we found out it's better not to do it because it's just not paying off. So that might be also our case. If they come off, then okay, we need 20 pieces a year and this and this complexities, then we say, well, sorry, it doesn't pay off. But if that's an okay, then it would take, depending on regulatory problems, of course, if it's a medical device, that can take very long. But if it's a non-complex device, inside of 3 months, we can ramp up production of several hundred pieces per month. Go to if there is another verification step needed in between, that might happen. To have, because sometimes in the first prototype you will need another loop. And then it would cost you something like 10,000 euros, 20,000 euros more to get the first serial prototypes ready, to test them, to improve the last thing. And then you're ready to go. You will have the 500 pieces per month, 1,000 pieces per month, 200 pieces per month. We ship you the sensor grids that you can integrate in your process, in your assembly of your product, and you can ship it out. There is the digital backend is ready. Perhaps you will have to make a nice user interface for your app to it. Perhaps our visualization tool is enough for you.
Interesting. And just to get this better, you mentioned a really important point about regulatory issues. Looking at Europe, how easy it is to get that for a newcomer, for a new manufacturer, or someone who is already there, but they're trying to implement this new technology,
If it's a product that's already certified and you just add sensors to it, it's quite likely that you can do that with a reasonable amount of effort. I mean, it's not a full certification then, it's just an addition. If it's a completely new product, this is tough at the moment. This is really tough in Europe because this new MDR regulation made a lot of confusions, a lot of problems, because all old products have to be recertified. There is a huge clog up of all the notified bodies that could do the certification. So sadly, this is something that makes the European healthcare or classic real medtech industry that's fully regulated currently a really big headache. Another way is, of course, first go to a market with a different regulation like the US, where things are getting much more smoother, where you can have your certification for a not too critical device that you have good verification data about inside of half a year. And then come back to Europe, because then it's easier because it's certified already in the US. Then it's easier to certify it in Europe. So that's a lot of companies are doing that actually currently. But the good thing is that the MDR gives a huge exempt for everything that's custom made. So if you have a custom made device, it doesn't have to be certified. It cannot be basically as thing, but only certain people are allowed to produce it. So in orthotics and prosthetics, these orthotic technicians, but they are our customers, or our customers employ them. So that's actually quite good loophole that it's still not entirely sure, because the MDR is so new, how this is actually will finally be put in place, finally work out. But currently our customers are not worried if they're doing custom-made devices. This is something they can do at their own risk.
I think you find a good loophole to find new customers.
Another nice loophole is that if it's a tool to just measure the patient, not for getting a diagnosis, but for fitting one of these devices, it's also not a medical, it doesn't have to be a medical device. If it just, like a tape measure or these digital scanners, also not medical devices, actually.
Yes.
It's so if you use our sensors to just measure, the shape of the patient, basically, that doesn't have to be a medical device. Of course, that if you give the data to the patient, then it gets critical. But then the software mostly is a medical device, and medical software as a medical device is another really, really strange topic. So we try. Of course, we pursue kind of both ways. So we try to keep our first applications, to have first applications that are non-medical devices, coming from sports, coming from fitness, nursing. But we also pursue the road towards these custom-made medical devices. And of course, we also have 1 or 2 projects on the horizon that will be real full-scale medical devices, but we know that these will be a much longer time scale. So we don't have to be certified, but our customers have to be. That means it takes some time. And of course, we have to also apply to a lot of regulatory conditions as a supplier of components. That's why we are currently doing the ISO 13485 quality management certification. That makes this much easier. But for a startup, this is really a culture shock.
People, the customers who are not into the medical devices. So which one would be your focus at the moment?
We currently have a project where the series production will start soon. It's an insole for bicyclists, where our pressure sensors help to, get the right cadence of cycling and also the right angle in pushing. So that's a smaller project, but it's good for us to get into a first series production and to run it. So this would be, for example, a project where we only supply the sensor hardware, because our customer has the electronics and the app and everything already in place. So for a customer in Germany, we are actually building a smart glove that can detect pressure and the absolute position of the finger, on the fingertips. And with this, you can, touch any surface and get the exact location in space of the points where you're pressing and also the pressure that you're applying. And with that, you can, for example, touch a patient, get this 3D scan while touching, and also some information how soft the surface is. And this is especially in orthotic technology. That's the space where we're most active in. This is a game changer because it makes the process of getting from a feel from the patient towards the 3D model in the computer that you can then design a device on that then is 3D printed. It can make that process much more efficient. But additionally, this has a lot of non-medical applications, also in reverse engineering and robotics, in all kinds of teaching where you can transfer this haptic information into digital data that then can be recapitulated. So what movement somebody did to achieve a certain effect. And perhaps also if the effect wasn't achieved, what was the reason for it? And so you can learn much faster because, again, you get feedback from what you're doing, quantitative feedback. So this is a project that can have, a lot of applications, both in the medical and non-medical field. And that we're rather proud of this concept.
Interesting. And if we consider that if let's say a hospital is trying to use what you are just showing the glove, and they don't have this, and the full feedback loop doesn't exist, what is the cost for them to get this whole feedback manually done? What is the duration that they will miss out if they don't have this?
Exactly. So in for example, in foot orthotics, where this glove could be used, you have the orthotic technician, which is who is a high-paid professional, very high demand. There are not so many people available to be able to do that. It's a 4 years education. And this person needs, without the glove, to get this data into the computer to be able to use the 3D printer. It takes about an hour using plaster and moving the patient's leg in the right place, then measuring the plaster and putting the numbers into the computer. While with the glove, it would be something like 5 minutes. And that makes quite a big difference, because that's the wage of the orthotic technician, that's the capacity of the facilities, exactly. So, and the throughput of the patients. So the revenue could be tenfold in the end, because there are much more patients that can be served currently.
Right, and I can also imagine if we can use this in a really critical situation, let's say wars like in Syria, or what is happening in Israel and Hamas situation, how useful it can be in those critical situations to get the feedback.
Definitely. I mean, this is now a bit of a more extreme scenario that is a bit further away on the development line. But of course, it's like in emergency situations where everything has to be done in very imperfect conditions. And if you can recapitulate what in this emergency situation was done to the patient, it can help enormously when you have it out of the line of fire. Then in more standard care to wrap up, find out what was missing and what still has to be done, things like that. And if you have that in the computer, you put a lot of load off the persons acting in the emergency response, because they don't have to communicate that personally with a lot of difficulties in getting this information extremely fast, extremely precise over. It's unbelievable. I worked in a hospital for a while, and it's unbelievable how advanced these communication systems are to transfer that information, but you lose a lot of it in the way, because it has to be unbelievably efficient. Of course, you lose a lot of things that then later give imperfect results. And if you have kind of an automated way to transfer at least some of that information that has been done, this could be a huge change and a huge improvement for those people affected.
It sounds amazing, because I can think of situations when, let's say, a patient is really in a critical situation in an ambulance, and they don't have to run through tests because they already have this sensor technology. They're already using it in the, let's say, ambulance, and they have the data by the time they reach the hospital. They already have the data and they know what to do.
Exactly. You get a head start in a sense. And on the other side, in situations like in the Ukraine, for example, where really a lot of people are affected, I mean, this is just like doubling, tripling. I don't know the exact numbers, but it's obvious that the number of amputees is surging enormously. And these are young people that have to, where it really has a lot of value to get them back on their feet quickly. And then any healthcare system is just put under so much pressure by these situations, where you need efficient ways to deal with that without compromising on quality of care.
I think this can be a critical problem solver. And if we now circle back to the market, because definitely the size of the market in terms of smart wearables is increasing. You talk about the Aurora ring, or there's one product which was recently launched as well, for using your hand to have those lights on the hand for using AI. So this market is definitely increasing, and it will for sure increase. But specifically in terms of talking about this soft sensor technology, what do you see the future of this? How will this be, let's say, after 10 years from now?
I think it will be much more common, in a sense that not in a sense, it will be much more common, because still, this all these electronics, AI have a big, let's say, there is something lacking to it. It's exactly that the data that's captured to feed all these data management systems, this AI interpreters and everything, is mostly generated by people sitting in front of a keyboard and typing it, or by taking pictures. So that's most of the videos. That's most of the information on the internet, and metadata generated again from that, or data that's generated, by cameras and by machines in motion, heart stuff. But this all is kind of a certain point away from what's really happening into our body, because our body is this distributed system. It's soft, and it's not very compatible with the electronics that we mostly use today. And to get closer to the human beings and having a more intimate look into what happens, because our movements, the fine part of our movements tell much more about our internal system than what you can capture on a camera, or what you can capture by typing down your feelings. So that's a huge reservoir of feedback potential that your body gives to the world, that you can then kind of feed into these into these information systems. For example, I mean, the big thing is predictive healthcare, a huge thing. That you're not going to the doctor if you feel unwell, because that's quite often too late and quite often far too early, because you will get better by yourself. And that clogs up, being too early there clogs up the health system. Being too late there is creating a lot of additional workload and suffering, basically. And to find this right spot when to engage with healthcare, and how to avoid having to engage healthcare by, just changing small parts of your lifestyle can, change the amount of suffering and the amount of healthcare, resources you need by quite a large magnitude. So, and their supportive devices can have an enormous influence. And for these supportive devices, of course, good to know these parts of your body that are not obviously known to yourself. Not obviously known to the cameras and everybody around you. And to capture these vital signs, you will need sensors that are distributed differently on your body, and that will interact differently with your body than what's available now. And that's soft electronics. You can only do that with soft electronics really reliably.
Indeed, I agree.
The sensors where you need them.
Yeah, indeed, I agree with that. I think more and more advancement in technology, the end user, the end customer wants to know what's happening with the body. So in past times, the smartwatch and watching your steps and heart rate and VO2 levels were not that common. Now it is the most common things. We are using those Apple Watch or any other watch that you use. And looking forward, this looks more optimistic if we have more soft sensors that can be attached, let's say, in your sole or in your t-shirt, that can tell you more data about you and can take better care of yourselves. Well, that so far was about the product, and let's now move on to talk about more about the team and who was building this product. I know you have an exit, you hold a PhD, you have years of experience. What about the other parts of the team?
Yeah, so two of my co-founders actually also were part of the institute that we founded out of the spin-off. That's mostly Daniela Wirtl, our CCO. She was in the institute. She has also a PhD in physics, actually, but she was already during her PhD and the years after more kind of focusing on managing research projects, collaborative research projects, with companies, with research institutes from all over the world. So she actually liked that much more than really the actual work in the lab, like getting these people and their ideas together. And that made her kind of predestined to be our CCO, doing everything around our customers. And as we pursue currently a very strong key account business, this is an absolute crucial role, because we want to engage in long-term partnerships with our customers. So typical lifetime value of our customers that we aim for is between 20 to 30 million euros. So you take care of your customers. and that will, come over time, over a time frame of 4 years, 5 years, 6 years. So this is very important to build up strong relationships and to know each other really well. And that's where we are actually succeeding quite well. So we are building up these partnerships with small and big companies alike, and it's really a good way to deal with customers is to have these partnerships. The second person from the institute is Thomas. He graduated in physics, and but he's have a second life, so to say, because he's very active in communal politics and is responsible in his hometown for finances and legal. I mean, you're always dealing with legal issues in politics, and he brought this knowledge and this passion into our company because of his physics background. He knows what we're doing, but he focuses on HR, on internal organization, and also on finances. And our fourth co-founder is Jana Vereshager. We met her a bit later, so she came into the founding team a few months after we founded. She was actually, she's also a scientist in applied mathematics and physics, and she did a lot of research in biomechanics and in medical technology. I did also lectures there, and she wanted to make her own startup with smart insoles. And we met in the course of these startup ecosystem events here in Linz, and then found out, why should we compete or do something similar besides each other? Let's just join forces. And she's now our CTO with a strong focus on also these kind of regulatory quality management issues. And that's our team. So I'm also a physicist, but it's quite some time ago. I founded my first startup company in 2009, and we made the exit started 2014, and by 2018 I was, it was complete, and I was more or less free to go. And as I said before, came back to university, and then Sendance started.
That's an amazing story that everybody in the team is either PhD or they have a great educational background, which is great. How long do you have known each other for? So like, how's the chemistry on the co-founders?
So Dani and Thomas really started studying together. So they know each other since more than 10 years now. I know them since 2018 closer. Because I always had relationships with that institute because it was also attached to my first startup company. So I knew them more like on a high-there basis in the office already longer, but it's kind of since end of 2018 we came together. And Jana, we met actually around the time when we founded Sendance in March 2021, but she fit right in. And of course, it's something we moved all the way from, sitting still in the university offices and labs and thinking about it while doing standard university stuff. Towards moving out on the campus into a small cabinet in the basement of another building, our first lab and office space. And then now we have over 400 square meters of office space here with quite a big lab and, 20 people working for Sendance. It is quite some transition, and I'm happy and that's really my personal passion also to keep that together, to do that and still staying a good team, because it's really a huge challenge. And I think a lot of startups fail at some point in that, even if they might continue, but they fail to keep being a team. And that happened in my first startup, and that was a lesson where I think I wanted to learn from that and try out if I really have learned from that, if I really can manage to avoid that. And up to now, we're really doing great.
Which is a good news. I hope it continues like that. Just before we head on to the 5 question round, I want to know, what would you say would be your North Star, let's say something that is beyond money that you want to achieve in far future?
That's, I think, we had a really good start there, because when we were sitting together during the founding and also in the month after, when things came together, is that we were absolutely clear on that we want to use the technology to help people, because we all know this scientific approach, working at university, writing in the papers, this and this wonderful things could be done with this technology, and then moving on to the next thing, because, then it's scientifically boring. And it was, all of us were this kind of, now we want to find out what happens when you actually do that. So, and that's what we are doing now. And this is keeping us also together. And if it's really, now we have several times already that, amputees really stepped into a socket with our sensors, and they saw what happens there. And they were immediately, the amputees themselves, without technical background, without business background, were immediately like, hey, cool, that's what's happening there. We like to see that, because it gives us this connection also to what we lost there. And this is something where I say, okay, we're doing the right thing. It doesn't matter if you sleep well, if you don't sleep well sometimes, or if you, argue about things days long, and if you have to, you get 100 no's from 105 investors you're talking to. This is what's, making sense. We're doing something that makes sense. And if we fail doing it, it's okay. We did something, it would have made sense.
Definitely. I think that's what it matters at the end, right? I mean, if you are changing people's life and making them happy, that's what it all matters. And I think everybody in the world is working towards that. So it's a valuable addition. I would love that. Let's hop on to the quick fire question round, and I'll give you a few questions that will help us understand maybe you and your life better. But for first one, let's say, what book, person, or movie has deeply influenced you?
Well, difficult. I would say I have a short list already. I have to The Never-Ending Story von Michael Ende. Die unendliche Geschichte. I would rank first. You know that one?
No.
It's a children's book by a famous German author, Michael Ende. That has this. It's kind of a hero's journey in a fantastic world. That has so many elements in there to, how to approach the world and what to be careful about. One of the most important lessons there was be careful what you wish for, and there is something better than your wishes coming true. Trust in the world. There is something so much better than your wishes coming true. It's just your wishes. There's so much more in the world, and just keep exploring. What you wish for is just, a lower limit in a sense. There is so much better things out there than your wildest dreams. So go out there and find them out, and be careful what you wish for if you're just too stuck in your wishes.
Right. I think I've also learned that lesson throughout my career, that not to stuck with what you want for, being more open in what world is and God is offering you.
Yeah, the classical one is if you're not careful, you will get what you want, and not what you need. This is for example, if you deal with customers, if you deal with anything that's not just like very obvious, but you have more complex projects, it's always focus on what you need, not on what you want.
Right.
And this is really tricky to distinguish.
And if you go to the next question, what is the best way you manage your productivity? Is there any method or something weird that you do so that you are on the track and not let's say, deviating from it?
It's probably checking in with other people. I always, if there is something important, sometimes I miss it, but I usually try then to involve somebody else, because if you're teamed up, I know I have a slight tendency to be a lone wolf, to do things on my own. feels more efficient. But then I have to remind, if I'm getting stuck in this, okay, leave me in peace, I'll do that. I stop now. I want to engage somebody else because they will kick me the right way. and they will, and I feel kind of, I have, if I promise them to do it, then, I better do it. It's better than if I promise myself because I'm too nice to remind myself.
Accountability, I think it's a big one that we all need sometimes to keep us right on the line. And what would be your go-to relaxation hobby outside your work?
Definitely, climbing and hiking. So the big solace I have is being up on a mountain. I don't know. It just developed over my life, but it's something I got stuck in. I'm also a trained mountain guide, and I like to guide people in the mountains. But it's really the really relaxing thing is being in a hailstorm on a sheer mountain cliff, trying to find my way in the fog, and then finally having made it, and then I have enough relaxation for another week. Of sitting in the office.
Is there any mountain in your bucket list?
Very famous. I'm not so keen on extremely famous ones. I climbed them if that's fine. But there are mountains on the bucket list, but people will probably not know them, more. But I'm mostly around in the Alps. But when I'm traveling somewhere, I always try to find a mountain nearby to go up on, no matter how unspecial they are. Now I was last weekend. I was in Britain, in London for a conference, and I just went to Wales for climbing up a hill there. It was really nice. It's just a hill, with grass and sheep on it. But
now I think we all need something to turn that work mode off, and you just stop thinking about it. That matters. And just to end before we end, last question. What would be, since you have already managed your own startup in the past, what would be one piece of advice you would give to founders out there?
Yeah, find a way to keep that lightness in a sense. Don't take things too serious. It's just not worth it. Something yesterday we had our Christmas or year-ends party here, and that's also what I said to the people there, because we had a rather tragic news 2 weeks ago. One of our colleagues died in an car accident, and of course that was affecting our mood. But I think it also was kind of, and the person that died was actually, as far as I knew him, he would have supported that. So it's not worth to get upset about, missed deadlines or about, some communication problems and things like that. Just, it happens, then you shout a little bit, but then go out and take a beer or a coffee and just laugh and have fun. Life is not worth, kind of being this. We need absolutely to do that. It's about, taking challenges, having fun failing, having fun succeeding. It's both fine. Failing is not worse than succeeding. It's just something different.
Definitely, I think
in the long run, or if seen from the perspective of you could die, next second.
Definitely, I think that's a wonderful way to end this entire conversation that we had, and I really appreciate that you came, gave us your time, and I hope that Sendance will definitely change the world, and I hope I will soon wear this one day in one of the manufacturers. Probably.
Yeah, of course you would like
Adidas.
But still, don't take,
Definitely.
Okay, thank you very much. Thank you very much, Raghav. It was a great pleasure. Thank you for your questions. Thank you for your time. And I'm looking forward to meet again. Well, the small class respect, and wish you all the best also on your way. And I'm sure we will meet again somehow. Goodbye.
Bye.